And now we will start with the first section of the Congress. We are starting with the topic of circular city. We will talk about effective use of city data and the way how they can help us create a circular city. And we will also mention the facts that circularity is essential in energy, food production, water and waste management sectors, etc., etc. First speaker with her keynote is Tamara Streefland from Netherlands. She will talk about making our cities circular through data. Welcome, Tamara. Welcome, Madam Streefland. Can you hear us?
I can hear you really well.
How are you? How are you?
I'm pretty good. How are you?
I'm great. I'm great. I'm really excited about today's topics. Welcome in camp. Welcome to virtual Prague City Data Congress. I will ask you about your presentation. It's yours.
Great. Thank you. So I'm going to share my screen. And there we go. Share. And now I'm going to press play. Oh, sorry about that. Let me just change one thing here. I thought, so is this better? Is this working? And now if I press play, you should all be able to see my screen, right?
Yeah, it works.
There we go. All right. So today, I'm going to minimize Zoom. Okay, that's not really working. So we're just going to do it like this. So today we're talking about the accelerating circularity in cities and how we can use data. So cities are the future. They're these centers of human creativity, diversity, and interaction, but they're also that are driving the global economy. They're also home to the majority of the global population. Cities are growing. So lately there hasn't been as much interaction. This is a picture I took a couple of weeks ago in the red light district in Amsterdam. We are living very strange times. Of course, we have the horror of a pandemic going on, but also it's a time where we are forced to go back to a more moderate lifestyle, really, really limiting our options. So even in the red light district, the tourists have gone, and I think you're experiencing the same in Prague, and we've seen the same in Venice, for example. Nevertheless, these strange times are also a time for change, and if we want to make change, cities are a great place to start because they're leverage points. So although they cover only 3% of global land surface, they consume more than 75% of all global resources, and the bulk of greenhouse gas emissions also come from our cities. And these resources aren't always divided equally and justly within our cities, but also between cities and more rural areas. So cities are growing, and as they grow, this will also be linked to more energy use, but also material use. So to provide in our needs, we are currently using this extractive economic model that is deriving from using virgin resources, also like monoculture production systems to provide in our food. And we're using a lot of land for this. We're taking away wild land, shipping goods all over the world, and wasting a lot while we're at it. So we call this a linear economy. We take, we make, and then we dispose. And with that model, we're crossing the planetary boundaries. So this is a model that is made by the Stockholm Resiliency Center. And what we see here is 9 planetary boundaries that we shouldn't cross if we want to keep our planet livable for human species. We also see some red here. So we've already gone beyond the zone of uncertainty for biosphere integrity, and that's really related to loss of like different species and biodiversity loss. And biogeochemical flows. So biogeochemical flows are phosphorus and nitrogen, which are critical building blocks for our food system. So we're not doing great. And this is leading to a lot of environmental impacts, both experiences in and outside of cities, often affecting populations that are already vulnerable. So we see desertification, toxicity of ecosystems, land degradation, the land that we so much need for biodiversity, but also production of food. We have piles of waste, floods within cities, and also air pollution. So we're crossing the planetary boundaries, affecting all life on Earth. So we need to design our cities so that they can grow without crossing these planetary boundaries or undermining the biosphere, while at the same time making sure that we have enough to thrive and dividing these resources between all inhabitants in an equitably and just way. And this is not news. I'm sure that many of you have heard of the Club of Rome. This is 50 years ago. We've known this for a very long time, and even before that. So we know about it, and there's all these theories out there. This is the theory of decoupling, right? So can we grow? Can we have more human well-being? Can we decrease poverty, but decouple that from our resource use? So not use more resources while we add it, so that we stay within these planetary boundaries. We've tried, but we haven't really succeeded. So this is an image of Earth Overshoot Day. So this is the date every year where we've used all resources that we should technically use to not cross these boundaries, right? So what we see here is that although we've known for a while, our resource use has gone up. And now we're almost using 1.75 planets to fulfill our needs. Efforts have been made, lots of conferences, lots of strategies, there's commitments out there, but we need to accelerate and we need to really form this into action. So can we act faster? So I'm sure that over the last couple of months, you've seen this graph. So what it shows is the exponential growth of COVID-19 cases. So if every person infects 2 other people, you will see that this grows. And then what is really the threat is the capacity of our healthcare system. So we needed to flatten the curve so that we were able to kind of manage that pandemic. So the Dutch government really recognized that. And what they did is they resorted to science to come up with their strategy. So over the last 3 months, we've been in an intelligent lockdown. So an intelligent lockdown meant that we had to keep 1.5 meters distance. All the restaurants and bars were closed. We are working from home, like in many other countries as well. And like many stores are closed, but we didn't have to go in quarantine in our homes. So as the pandemic progressed, these measures were adjusted based on new developments and new models of the Dutch Public Health Organization. The newspaper gave daily updates on how many new cases of COVID were there, how other countries were doing. And then the Prime Minister, the one in the middle here, gave a bi-weekly conference together with the principal of the RIVM, the Dutch Health Organization. And they told us what we can and cannot do. So the amazing thing is that what I saw is that everybody's listening. So we are all following his lead. We're taking our distance. We're taking responsibility, and this is driven by science. So the Dutch government has really resorted to scientific models and the data to that is at the basis of them. So there are more exponential growth curves out there. So this is again related to these planetary boundaries, and what we see is that as population grew, also global biodiversity exponentially decreased. Our water use on the top right exponentially increased, and our fertilizer consumption as well. So can we flatten these curves? So going back, our cities are growing, and we are crossing the planetary boundaries. So we need to revisit that economic system that we're having, that extractive, linear economic system. And that's what we're working on with Metabolic. We're working on transitioning the global economy to a fundamentally sustainable state as soon as possible. And we've been doing that for about 8 years, from starting in our headquarters in Amsterdam. And we've grown it up to almost 50 people. And Metabolic is not an average, not an average, a normal company. It's more like an ecosystem. So we have a consulting branch in which we advise governments, industrial clients, but also NGOs. We also have a think tank that really looks at new data-driven methodologies to support the work that we're doing. And then we have a ventures branch because we really believe that implementation is a driving force into making change. So we also shoot these new ventures into the world. One of them is Spectral, for example, a company that is focused on the energy transitions and smart grids. So one way of changing the economic system is by going from a linear model to a circular model. So a circular model, again, is one in which we stay within these planetary boundaries while at the same time having enough resources to thrive. And when we think about the circular economy, oftentimes we think about recycling, right? Materials. I'm sure that every one of you has looked at or has had an old phone before that they might have sent to recycling, or another old piece of electronic, but we have to be mindful of where that is going. Is that being shipped to China, and who are the communities that are taking care of that? We don't want to shift burdens. So therefore, we came up with a model for circular and inclusive cities. So in this model, we start with materials, right? Materials in the circular economy are cycled continuously at high value. But all energy is also based on renewable resources while we're at it. Water is extracted at a sustainable rate and resource recovery is maximized. Biodiversity should be structurally supported. So an action that we do, so we shouldn't make materials that are really degrading land and taking in the space where other species could otherwise thrive. Human society and culture is preserved, and of course also human health. And then finally, we have to think about value other than financial. So not only thinking about the monies, but also about values like time or education, or time spent with your loved ones, or something really beautiful, aesthetic. We undertake every project that we do from a systems approach, right? So that's about understanding the complex dynamics and interactions within a system. So it's kind of like this Rubik's Cube. So you start with materials and then you run into all of these other pillars. So this really gives us insight in what are the root causes that are causing these negative impacts, so that we can also come up with interventions that truly address these. And this model avoids burden shifting and provides insights in the trade-offs of different new models. So we've kind of translated that into a methodology. And this methodology we use both for our work with cities, and we also use it for our work with industries. So we start with understanding where we are. So really mapping the impacts, mapping the system and the dynamics that live within it. Then we take that as a basis to develop where we want to go. So we set a vision and tie that to targets. And then we start backtracking. So what are the interventions? What are the solutions that we need to achieve that? And then the hard part comes, because I think many of you have seen strategies. There's so many strategies and out there and reports and all of that. Implementation is a crucial part. So what we really strive through as a company is to stay involved and to really make that translation. So we want to develop business cases, for example, with all multi-stakeholders collaboratively do that to really see where the momentum is. But we also want to be part of kicking off projects and finding new funding opportunities or creating these new networks. So we recognize that implementing circularity requires action on multiple scales. So if you look at cities, there's, of course, circular buildings and what that looks like, right? What does circularity on a building level look like? And how do these buildings interact in a neighborhood? Thinking about neighborhoods, can neighborhoods have different functions within a city, right? Can one neighborhood contribute to the energy goals of a city, or can the other one be more of an urban mining hub? And then finally, we also look at cities. So we do like these city scans, and that's also what I'll be focusing most on today. And we also address regions. So using data to accelerate the circular economy, like I mentioned before, we have this systems approach, but a lot of that is we have a lot of data models underlying that. So we really use data to understand what the systems dynamics are. So I wanted to kind of walk you through a couple of methodologies and use cases that we have. Starting with that first step. So how do you take where you are as a basis to then go into implementation and making change? So 2 years ago, we worked with Circular Charlotte in the US. We've worked with other cities as well, like in Rotterdam and in Amsterdam, and also we're doing a lot of work in the rest of Europe and in Asia. But Charlotte proves a nice example. So it's the first city in the US to make a commitment to adopting the circularity principles. Charlotte had an issue with waste because, as some of you might know, China stopped receiving some of the recyclables of US cities. And so they had to do something else with their waste that kind of like triggered them. They also had a problem with social mobility. So people that are born in poverty, it's hard for them to get out of that. What we started doing is really first looking at who are the stakeholders, right? So mapping the stakeholders who are part of this waste system. And, we took the waste system as a point of departure, and then you'll see that will come into like these other sectors. But what administrative boundaries are we looking for? How can we collect data best? Where does the data live? And then we also made it spatial, right? Where is the infrastructure of the waste systems based? So what we saw here is that a lot of waste infrastructure is actually located in low-income neighborhoods that are also suffering the environmental impacts of this waste system. And then we did a current state analysis in the form of a material flow analysis. So many of you, or maybe some of you, might have seen this already. What we see on the left side is, I'm thinking that you are all in front of your computer. So on the left side, we see where waste is produced, right? So households, commercial entities, the construction sector, but also the public sector. And then we have the total amount of waste that is produced. We separate that into fractions. So what are the types of waste? And then we see where it is going. And what we saw in Charlotte, and you'll see that in a red box on the right side, is that lots of it is going to landfill. And that's actually a leverage point. So we use these current state analyses to identify where to intervene in the system, so to make the most impact and create most value. So here, so we identify a couple of these hotspots, or opportunities, as you might want to call them. So these could be building waste, plastics, organics, but also maybe collection systems and how it goes. So in Charlotte, we saw that if all plastics landfilled are actually recycled, this could save a lot of barrels of oil, but also create revenue. And a nice translation we made there as well is like it could create jobs, which is something that is important for the city of Charlotte. So then we use that current state analysis and understanding the system as a basis of developing a vision. So for Charlotte, we were focusing on waste, but also on innovation, like really making an innovative environment. A city that is resilient and healthy for all of their inhabitants, but also a city with opportunities. So that's really, again, like relating or tying back into these jobs. So we link this vision to KPIs to monitor, because of course, like if you set a goal where you want to go and you come up with a strategy, you never know how it plays out, because maybe there's some unprecedented effect or things that we couldn't predict. So we tie these visions into KPIs, so measurable targets, so that we can see if we're still on track, and if the interventions that we're implementing, if our actions are really achieving the goals that we want to, or the vision that we want to achieve. So then, of course, like thinking about data, it's also important that we can have access to that. So when we set up a KPI framework like this, we also look at where you can collect the data and whether that can be automated, or if that's something that should involve different stakeholders. And of course, it's most optimal if you can also then tie that to a dashboard. So we know where we are, we know where we want to go, and then we look at interventions. So we often start with a long list, and these can be physical, social, or economic, political interventions. So they can be policies, but also something that you really have to implement in the built environment. So think about circular concrete, or new ways of processing organic waste, such as fruit batter or black soldier flies, which is this really cool bug that can really deal with organic waste. Also think about new collection methodologies. So then we assess all of these interventions on their potential to make impact on achieving our vision. Right? So we are looking at impact. So, right, we have models to calculate that, but also feasibility. So when you think about feasibility, this is also about the readiness of an organization to implement something like that. Is the intervention we're talking about actually proven technology, right? Is the technology ready? Is it financially viable? Are there stakeholders that want to implement this? So those are all things that we have to take into account when thinking about implementing interventions. So we use this framework to go from a long list to a short list. And then we come up with a roadmap. So things that might have a high impact but are a bit harder to achieve, we might not start with that, but that might be a second step. And we really try to plan these roadmaps at over a timeline. So as I was mentioning, like one of the important parts of data, like there's so much of it, and is making things imaginable for people, right? So really trying to get everyone on board is one of the things we're really trying to work towards. And we see that business cases really work for that. So we always try to calculate with these interventions, not only what benefit they might have to mitigating some of the negative environmental effects, but also looking at what kind of jobs can they create, and also thinking about the value that is out there. So for Charlotte, we calculated 5 of these business cases, and we saw that in total with these 5, we can approximately limit 100,000 to 150,000 tons of waste, create jobs, and also reduce these environmental impacts. So we're really trying to create insights with data as a basis for driving implementation. So this is something that Wojtek, after me, will talk about, and I'm really curious to hear. Prague has gone through a similar process, so looking forward to hearing that. Okay, so we talked about implementation. Implementation in the built environment, that is not always easy because cities are built, right? So how do you go about that? So one project we did together with TU Delft and the AMS Institute a while ago is Repair. So what Repair did is it mapped organic waste flows for the metropolitan region of Amsterdam. So what we see here is the size of the organic waste flows, but we could also determine the types of fractions, right? Like what type of waste is it? We could also see who produces the organic waste and then also where it is going. So this is a very nice basis of then understanding what can we use of this organic waste and who can use it, right? So and then you can tie that to eco-innovative solutions such as, or local businesses, new innovations, such as going from like using bread waste as a basis of brewing beer, but then also the other way around. So this is using these material flows as a basis of getting towards new innovations. We can also turn it around, right? So if we have a vision and we know what interventions we want to implement, it's important to look at the characteristics of a neighborhood, right? Some neighborhoods might be post-industrials, other might be, like monumental city centers, and these require a different approach. They can also, contribute to citywide goals in a different way. So city center of Amsterdam is going to be very difficult to make energy neutral, but this is again like easier in a post-industrial developing neighborhood. Yeah, so think about the different neighborhood characteristics when implementing interventions, really map out the enabling context. So we use these different layers in GIS systems to then, so geographic information systems, to then see what fits where best. So what can we implement where to make the most impact on achieving the goals that we have set? Finally, prospecting the urban mind. Data is also very suitable for making predictions, right? So another material flow analysis, this time for the city of Rotterdam. What we did there is we looked at different sectors. So we looked at the agri-food sector, consumer goods, building and demolition, hospitals, but also, of course, at water and energy use. One thing that came out of that bigger material flow analysis was in the construction sector. So what we saw is that a lot of building and demolition waste, and you can see that at the bottom right of your screen, was actually downcycled. So this is again like a leverage point. So we identified a couple of interventions, so strategies. So you could reduce, right, the amount of building and demolition waste by making sure that we don't, that we have efficient planning. A lot of construction waste actually gets wasted because, during the building process. We can synergize. We can link building projects, like new developments, to demolition projects, and then kind of promotes the use of secondary materials. We can also see how we can limit the impact of the construction sector by giving land tendering guidelines. So can we produce and purchase materials that are actually environmentally sound, and of course also healthy for humans? And then management. Can we, in new developments, map the type of materials that are in there through material passports, so that when they are demolished, they're actually it's very clear how we can use them, right? So that they don't have to be downcycled, but can be used up to their most potential. So after we built this strategy, we collaborated with Blue City in Rotterdam, which is our partner that was also part of the initial the initial project, but also the municipality and other partners to take forward a building and construction hub. So building and construction hub is a place where you can store materials, secondary materials, to then bring them to another project. So it kind of overcomes this time gap that the construction sector is sometimes running into. Now, this project was about finding the optimal location for storage and processing these materials in the city of Rotterdam. So to go about this, we have an urban mining model. So what this urban mining model does is it predicts the material flows that will become available, the material stock, basically, building materials, over the next couple of years. So we have a big database where we can model that for 12 different building typologies. And then we have an image of what will become available. So we know ballpark how much. And that, of course, is very important when you think about what the size of a building hub should be, right? What is also important is where it should be located. So what we did is we mapped these materials over the map of Rotterdam. So what you see in the red dots is the demolition project and the size of them correlated with the size. And the green ones are the new development over the next period. And then what we try to do is really see if we can map them and find an optimal location. So this is a simulation of that. So this is where a building hub could take place. So some takeaways in regards to data. One of the things that we find really important is that data should be made visual. So we have a wonderful team of graphic designers that really work on making beautiful infographics. So these that can really show the complexities of the systems, but also make it widely accessible for all these different stakeholders, right? So we saw this bunch of people in Paris at the beginning. They should all understand what these systems are doing, right? So, and how we can change them. Sometimes data is unavailable. In that case, you might need to resort to upscaling or downscaling from national data or community data, right? And you might have to use research to fill the gaps. Or, we should also always talk to stakeholders to see what gaps they can fill. Setting up a monitoring framework is key to driving meaningful change because we need to be able to adjust our strategies. And then implementation can help ground truth a model and also these assumptions. So we can optimize our models like that. And that's also what we did with that building hub that we just used. By trying to implement that, we saw that, what stakeholders are really important and also, of course, got insights on what rules and regulations there are at play. Moving forward, how can we now accelerate and drive implementation? So there's a couple of steps that we could take to really, there's many cities out there. We have to make a lot of change, and we can't, go from city to city to city because it will take a long time, and we need to act now. So we can share methodologies, right? Like this is an example of how to go about circular land tendering, but you could also share methodologies in terms of like how to go about these data-driven approaches or how we build a material flow analysis. We could also, if we are monitoring, we can also share databases of evidence-based interventions. And I'm not saying Metabolic should share, but we should all share, right? Like there's so many cities working on this. Like, can we all exchange? What could also help is that we create the tools and dashboards to support all of that. Like to support implementation, for example, but also monitor our change. There's so many organizations working towards implementing the circular economy. Wouldn't it be awesome if we would all work together to, synthesize our knowledge and build these tools for other organizations to use as well? And then finally, there's a lot of data out there, but sometimes it's just not accessible. So, many people are collecting data. It would be great if that could be shared, but also there's, sometimes data cost money. So it would be great that if we have projects, like governments would open up their data, but also if we have done projects, have collected data and models, we would all have a common data repository where we can bring this together for everyone to use. And then finally, going back to the government of the Netherlands and how they are listening to science, maybe we should bring it out there more. Maybe Mark Rutte, our Prime Minister, should from now on have a bi-weekly conference in which he talks about our progress towards achieving the climate goals. Maybe we should also report on the impacts of, the environmental impacts that we are causing with our, for example, with Amsterdam elsewhere. And maybe we should also, adjust our strategies based on these insights. So really monitor our goals closely, and then also, of course, take responsibility for that from a community or individual level, community level, but also, of course, national governments. Closing it off with another picture of an empty Amsterdam. This is Dam Square, and I've been doing a lot of walking around the city, and I've really realized that this is a time for change, and I hope that we can really collaborate to see how we are now going to accelerate. Also, of course, with the economic crisis that is predicted. This is seen as a time for change, but let's all work together to also leverage that. Thank you.
Thank you very much, Tamara. That was very interesting speech, very interesting keynote. I'm really happy that you joined us and started the section about circular city. This topic is very important. So thank you very much for joining us.